Hello everyone. Welcome to Contemporary Software Development at Portland State University. In this screencast, we'll continue our exploration of code refactoring with a focus on smells that can occur in object-oriented code and on specific refactorings that can help make code less smelly. We'll see how fields, methods, class hierarchies, and delegation can be used to improve the intent of code so that it can be modified more easily and with less risk. So as more and more object-oriented code was written, there were some common code smells that were identified that emerged over time. We'll explore some of these code smells and refactorings that help alleviate them. So there's something called primitive obsession, message chains, middleman, and data classes. These are all smells in object-oriented code that we can get rid of with refactoring. Now, primitives in object-oriented languages, these are things like ints and doubles and strings. So technically strings are objects in Java, but they're primitive in that they're part of the API and they're pretty basic. These are very valuable, but they're deceptively easy to use. So just because you can use a primitive for something doesn't necessarily mean you should. So when primitives are used to represent money, dates, phone numbers, number ranges, you have a data that's measured with units, something like miles per hour, it can get really awkward to use primitives in these situations, and you can have inadvertent bugs in your code. You also end up with a lot of what I would call C-style functions that operate on the primitive data and perform things like validation on them. You also end up with a bunch of magic numbers or magic values whose intents aren't necessarily clear just by looking at the data. What does the number 5 mean exactly, right? So I'm going to talk about a couple of refactorings that can help break our primitive obsession. The first one is to replace a primitive with an object, in which you provide a representation of the data as an object instead of a primitive, which provides more richness or is tailored for that particular situation. Replace type code with subclass takes the logic that operates on type codes, these again are those magic numbers, and replaces it with objects and instances of classes, each of which has its own behavior. Similarly, the replace conditional with polymorphism refactoring uses methods to route and distribute complex logic over multiple classes. And finally, the introduce parameter object is a refactoring that groups primitives that are sort of all tethered together into a single object. So let's talk about the first one, replace primitive with object. So using primitives to represent data that they're not, if it's not, an int is a number that you perform arithmetic on. Should it be used for anything else? That might be okay for a little bit, but as you use it more and more, the true intent of that piece of data becomes clear, and representing it as an int is no longer useful. Consider also something like a phone number. There's behavior that's associated with that phone number. You want to validate the area code is correct. You want to format it so you can display it appropriately. Representing a phone number as a string throughout your program makes it more difficult to perform that validation and formatting. And even if you can live with representing something like a phone number as a string, the logic that operates on that string might be duplicated in multiple places within the code base, and the duplicates might not be exact clones of each other, and there might be bugs that are lurking in there. So in this refactoring, what you do is you create a new class that represents the data, and also contains its behavior. Now normally this just starts out very simple. You just replace a primitive with an object that wraps the primitive. But over time it likely grows. So once you have this new class, you can replace the uses of the primitive value with instances of the class. Now this doesn't come for free. One of the nice things about primitives in these languages is that they are more efficient at runtime, but you're making a trade-off. You're saying, okay, I'll give up a little bit of real or perceived runtime efficiency in order to have a code base that is easier to reuse and easier to extend. When you realize that you've got a primitive that has outlived its usefulness, you might want to consider using an enum type, especially if there are only a small number of potential instances of the class that you introduce. Now, another common use of primitives that might not be fit to purpose is type codes. Now, type codes are used in software to represent different kinds of similar things, like priorities. Priorities 1, 2, 3, 4 through 10, or a job type, or some sort of like national origin on some survey. Right? You choose a code that represents something bigger. And as more categories are added, or as you end up implementing more logic that depends on one of these type codes, it might make sense to replace primitive type codes with a class hierarchy that more richly represents all these different types and categories. What this gives you is one place to put things like validation logic and any shared behavior, right? You can put shared behavior into a common shared superclass. And all of that conditional logic that used to be in if statements or switch statements then is replaced with polymorphism, meaning that you've got a method that you call to perform some piece of logic, and depending on the runtime type of the object on which the method is invoked, you'll get the conditional logic that makes sense. And since you've got a class hierarchy that represents the categories, any additional state or behavior that you need naturally fit within subclasses within that hierarchy. Alternatively, it might make sense to subclass the type that uses the type code for each individual class of the type code. So for instance, if you're modeling an engineer, should an engineer be a subclass of an employee, or should it be an employee with an engineer role? There isn't a hard and fast answer. It all depends on what makes sense at the time. So there's some things that you should keep in mind when you're looking to replace a type code with subclasses. While you're in the middle of this refactoring, you'll probably want to retain the type code in the class hierarchy someplace, because it's still a first class value within the code base, and as you're removing it, you'll need it temporarily. You can also use a factory class or a factory object to instantiate the subclass that corresponds to a particular type code. This keeps all that logic in one place and makes it easy to remove once you're fully completed with the refactoring. Conditional logic that are in switch statements, that can be moved to a superclass, and then as you're refactoring, you can override that method that has the conditional logic with the appropriate behavior for each subclass. As you're evolving your code to apply this refactoring, you can use exceptions that basically convey that it's not implemented yet to smoke out any places that need additional implementation or consideration. In some situations, it isn't possible or practical to subclass existing classes. Using a delegate object to perform some of the logic may be appropriate. Another situation that often arises when you're using lots of primitives is that you have long if-else chains or switch statements that have a lot of conditional logic in them. Especially if you've got branches of these conditional statements that contain complex or very specific or distinctive behavior. In that situation, taking that logic and moving it to a class hierarchy instead might make sense. This is especially valuable when you've got branching logic that occurs in multiple places in the code base. You can avoid duplication by leveraging the superclass-subclass relationship to keep common cases in the superclass, and then when things vary for specific types, put those in subclasses. One of the nice things about this is if you need new logic, you no longer need to add another branch to the if statement or the switch statement. Instead, you just add another superclass. It keeps the code more isolated, better encapsulated. Now, you can probably imagine how all of this works. I'm not going to go into a lot of detail, but you end up applying a lot of the same things that we did for replace type code with subclass. You introduce a class hierarchy and move the code to the appropriate place in it. The second code smell that we'll explore that sometimes happens in object-oriented programming is something called message chains. Now, a message chain happens when you have a bunch of getter methods that are invoked along a series of objects to finally get to an object that's of interest to the code. Sometimes you see this as literally, this object.get, this other object.getField.getField.getField. But more often you see it as a series of intermediate objects that get assigned to variables. The reason that this is smelly is because it couples the code that wants to use the object to the series of steps it takes to get to that object. All that navigation there is exposed to the caller. So as a result, if you have objects whose relationships change, all of a sudden this client code needs to be updated to reflect that. So there are a couple of refactorings that you can apply to help remediate this smell. First one is called hide delegate, and basically what that does is that you have an object that adopts some of the behaviors of another object and then delegates off to that real object to do the heavy lifting. You can also use extract method, which we've already talked about, to centralize the message chain code in one location. That'll clean things up a little bit, and limit the blast radius if the relationship between the objects changes. And also move method, which does exactly what it says. It moves methods around so that the code is better organized for both visibility and reusability. So you've got one object that delegates to another object to perform some operation. The hide delegate refactoring encapsulates that intermediate object and makes that behavior available to the higher level object. It makes it much easier to change the object relationships without having as much impact. A simple example of this is, let's say that you've got a person object and you want to format the birthday, so instead of calling getBirthday.format in whatever format you want, you just put the format birthday functionality on the person itself. And so it hides the details of getting that birthday object and then formatting it. So in this situation, it's that birthday object, which is the delegate object that I was talking about, because the person delegates the responsibility for formatting the birthday to that birthday object. But the client code that uses the person, that just wants to deal with a person, can call format birthday and get the same functionality. The other refactoring that's good in this case that we haven't learned about already is move method. When elements of a software program, of classes and methods, fields, all that kind of stuff, are organized into a logical grouping, you get more modular code. And it enables changes to be made to that code without understanding all the components of it. Right? I say that this limits the blast radius of your changes. And so when you make a change, you can feel more confident that you know what other code needs to change around it. So as your code evolves and as you feel more confident in your ability to understand it and make changes to it, you'll probably see places where you can reorganize the elements just by moving it around. Right? So maybe you've got an element that's used by other elements in one context more than in the context that it's currently in. And so you want to move that method, you want to move that field closer to where it's actually used. You might also find a method that would benefit from having a slightly broader scope, right? Making a private method public, putting an object in a place where it can be more easily found. Or maybe as you're writing more code, as you're writing more classes, there might be a class that is now a better home for that element. Maybe there's some data that it uses that exists in that other class, and so you move it from one class to another. It just feels more at home. While you're moving methods around, there's some things to keep in mind. If you're looking at a method and you're unsure, or it's really difficult for you to decide where the best place for it is, it might be an indication that it's not quite ready to be moved yet. And that's okay, right? We can always move it later when a solution is more apparent. You might find that there are some methods that have interdependencies that cause them to want to move together. And that's okay. You can do this. Now, mechanically, it's easiest to start with the methods that are called least often, kind of the internal ones, if you will, and then move to the larger methods. An interesting technique for this is that you first inline those methods that are called less often into the ones that are called more often. It results in a larger method, temporarily, which you can then move that code someplace else, and then reconsider that large method for refactoring to extract the methods that might be different from the original ones in a way that makes sense. Now, when you're moving methods around, make sure that you understand the impacts of any methods that it might override or any subclasses that might override that method yourself, right? Think about that. You've got a class hierarchy, and if you just move a particular method and its implementation out of that hierarchy, all of a sudden you have subclasses that now override a different method, so that behavior might change. Luckily, if you have automated tests, you'll be able to catch those problems. And finally, if a method references fields in one context, you very likely will have to pass the values in those fields into the new context. Sometimes that's okay, and sometimes that makes the move not so compelling. Now here's another code smell that is related to encapsulation. It's called the middleman. Now, encapsulation is good. It has many fine qualities. It helps make your code easier to understand. It puts responsibilities in places where they belong. But sometimes that encapsulation can work against you. So, again, if you have an object that has a bunch of delegate objects, and then that object that delegates ends up taking on too many of the responsibilities of the delegate objects, then you've kind of got a bloated object. It does more than it needs to, or it's got a bunch of methods that just delegate off to other objects. That can get really hard to work with. What do you do in that case? Well, you can remove the middleman with that refactoring, where you basically expose the delegate, and so then the client uses the delegate object instead of the object that delegates. Another refactoring that will help with the middleman smell is to inline methods, which basically removes that encapsulation when it isn't valuable. And then finally, the replace superclass with delegate refactoring, which will, when you've got some extra behavior, it basically puts it down to the middleman to perform that behavior in the delegate instead of code having to use that delegate to perform the behavior. So let's talk about this remove the middleman refactoring. So you've got an object and it takes on all or just too many responsibilities, the methods, of its delegate object. In this case, it says just expose the delegate object and have whoever wants to call that method just call it directly on the delegate. Now, this can be a difficult decision to make because it breaks encapsulation. And so now, it's really a judgment call in terms of whether or not you think that exposing that delegate object makes your code overall better. But luckily, it's pretty easy to go back and forth. If you decide that exposing it isn't the right thing to do, or maybe there's something about the delegate object that changes that you no longer want exposed, right? You can go back and you can always change it. Here's how you do that. Here's how you remove that middleman object. First thing you do is you create a getter method that exposes that delegate object. And then for all of the calls to the methods that delegate to that object, just replace it with a call to the getter and then have it call the desired method. Now notice that the remove middleman refactoring is basically the inverse of hide delegate, right? And this is okay. This is very common in refactorings to have them have these mirrors, these inverse of each other, because sometimes you want to do both, right? There's some cases in which you want to introduce encapsulation, and then other cases where you want to break the encapsulation when the encapsulation isn't fit to purpose anymore. Another refactoring for object-oriented programming is inlining methods. So let's say you've got a method that is short. I only got a couple of lines, which we like, right? We like short methods. It's clear and easy to understand. As a matter of fact, it's so easy to understand that having like a good name for it doesn't add any value. Well, sometimes that method isn't very useful to have that simple line of code in its own method. In that case, just replace the calls to that method with the body of the method, of the code that's in the body. The lesson here is that oftentimes indirection is helpful. Providing that well-named method can make the code a lot easier to read, but sometimes it's not. Another place to use this is when you've got a bunch of small methods that kind of seem awkward or ill at ease with each other. Sometimes you can inline them to get a long method and then take a fresh look at that now longer method and extract new methods that maybe have different names or pass their data differently. And a very common use of inlining methods is to, again, expose that delegate. Oftentimes what the method that delegates does is it gets the delegate object and calls a method on it. Well, that's a pretty short method. And so then inlining that to all of the callers basically has them get the delegate object themselves and call the desired method. Again, just like we were saying in the last refactoring, you need to be aware of the impacts of polymorphic methods, so overriding or overridden methods, when inlining and moving things around. Now, if you find yourself looking at a method that recurses, that calls itself, or maybe has multiple return points, this is likely too complex to warrant a simple inlining. And so maybe that's when you back off from. And you say, well, even though it's pretty simple to understand, there's enough complexity there that it's not worth trying to inline that into its callers. So object-oriented programming is great. Class hierarchies are great. But one of the things about class inheritance is that you inherit all of the code, all of the behavior from your superclass. This makes it really easy to reuse all that code, but sometimes you don't want to reuse all that code. Or more specifically in this case, you don't want to expose all of the behavior that you inherit from your superclass. And so what this refactoring does is it replaces the superclass relationship with a delegate. So in this case, we're introducing a delegate in order to better encapsulate the behavior. So to get rid of situations where you've got a subclass that has too much behavior, too much state inherited from its superclass, what you do is you turn is a relationship, so the inheritance relationship, right, the subclass superclass relationship, into a has a relationship, into a delegate. So the one object, which is probably the subclass, breaks its relationship to its superclass and instead uses an instance of its superclass to perform the behavior that previously inherited. This means that the object only delegates, and therefore exposes, the relevant operations from its former superclass. And just like with any delegate, it may or may not be exposed to clients. It all depends on what fits the purpose. So how do we enact this refactoring? Well, remember, you start out with a class, and it's got a superclass from which it inherits more behavior, and more importantly, exposes more behavior than it wants to. So first thing you do is you create a field in that subclass that will refer to a new instance of its superclass. And then what you do is in the subclass, you go and add methods that are relevant to its clients that used to be inherited from the superclass or overridden for the superclass, but instead delegates off to that new field that you added that refers to an instance of the superclass. Then you go look at the callers of those inherited methods, and then you replace those calls to the inherited methods with the newly introduced delegating methods. And then you remove the inheritance relationship, right? No code is relying on that relationship anymore, and so you no longer extend that class. Now, when you do this, you might need to do things like clean up the constructor to no longer call the superclass, and there might be some other little things to change there. But these are the steps that you go through to pull apart a superclass-subclass relationship and replace it instead with a delegate relationship. Another object-oriented code smell is called data class. Now, data classes are very simple objects, right? They have some fields, they have getters and setters, and that's it. These are fine. And these kind of work well, but there are some ways to implement these that are kind of smelly. So for instance, if you have a class that just has a bunch of public fields, first thing you do whenever you see that or want to refactor that is just replace them with getters and setters. And remember, you only need setters for fields that are mutable, the fields that are changing. So if no one assigns to that field, you want to encapsulate it inside the class so that no one can inadvertently set it. Now, kind of like with primitives, data classes often end up with code outside of them that manipulate their state. Not just get and set, but will update various values. And as a result, you end up with kind of code that's far-flung. It's hard to look at the data class and you can't find out what code actually works with it or what that code really does. However, note that data classes aren't always a smell. It's okay to apply a refactoring to take a bunch of primitives that are parameters to a method, put them all into a data class, and use that data class object to call that method. So data classes are fine, especially when you've got a bunch of immutable data. However, when you end up with a smelly data class, where there's lots of behavior that's flung all over the place, or you've got state that is exposed, here are some refactorings that you can apply to reduce that smell. The first one is called encapsulate record, which basically takes a data class, a record, into a sort of a real class that has behavior associated with it. Second one is called remove setting method, which basically makes objects immutable. You can also use move method to move code that manipulates the record, that manipulates the data class, into one place, into that class. And then also extract method here is useful. This will take a big long piece of code that works with a record and puts it into other methods that'll make it easier to read and easier to reason about. We've seen some of these already, so we'll just focus on the ones that are new to us. So the first one is encapsulate record. Now, when I say record here, I mean it's a data type that only has structure and no behavior associated with it, and nothing that encapsulates it. So think like a struct in C, or in language like Python, where you have those maps, those hashes that just have a bunch of key value pairs. This is often used to represent data and does it well. I mean, no question about it. However, you can't encapsulate things inside a map, right? All the data is there, and the behavior that manipulates that map, it's someplace else. It's not right there with the map, because while there is a data structure, there isn't a class. Records are particularly problematic when you've got data that changes, mutable data. Because all of the data is external to the record, all the things that calculate the values, that update things, it's hard to figure out if the data and when the data actually changes. And because the data is exposed to everybody, you can't rename a field in a struct, in a record, without it impacting all of the callers that use it. Contrast these properties of records with a class. A class makes state and behavior very explicit. It has methods for data encapsulation, making fields private, for instance. And it has the ability to put the behavior right there with the class. So all of the code, the state, and the behavior is localized together. So for instance, when you create a class that is evolved from a record, you end up with accessor methods that provide the same structure of the record. And then you just go through and you replace uses of that record with instances of the class. Conceptually, it's not very difficult to do, but it becomes kind of time-consuming, especially when there are lots of uses of the record out there. Another object-oriented refactoring is removing setting methods. So setter methods are things that mutate fields, that put new values in. This makes the objects mutable. And you see these a lot in frameworks that do things like make it very easy to populate some object from the context of a file or some other external data source, things that will map the structure of your relational database into a bunch of objects, or mapping something like XML into objects. Really great to have that, and they often rely on objects having getters and setters to populate data automatically from some external structure. However, if logically you've got data that shouldn't be modified once the object is created, then you shouldn't have a setter method, because that gives permission or gives the ability for any code to change that value. Not having a setter method makes it very clear that that field is immutable, that once the object is created, that value should not change. So if it's appropriate to do so, we should remove those to make it, again, very explicit what's immutable. So how do we go about doing this? Well, we can use a refactoring like change function declaration or change method declaration to put the initial field values into the constructor, right? So things that used to be populated via setters, put those as parameters to the constructor. Also, in a language like Java, we can mark the fields as final so that they are only initialized in the constructor, and then we remove the bodies of the setter methods. And now you've got empty setter methods, and so you can use the inline method refactoring to find all of the call sites of the setters and turn them into zero code. So there's a lot more that we could talk about refactoring. There are large catalogs of refactoring techniques out there, and maybe in the future I'll include some more information about them. But this is plenty for today. So in summary, your code can evolve over time, and it really should evolve over time as it grows to solve more problems that are important to the people that use our software. To help aid that evolution, refactoring code makes it easier to understand and therefore easier to extend. Refactoring doesn't change the behavior of the code, only how it's represented. And just like with many things, taking smaller steps and working with smaller chunks of code make it easier for humans to understand it and to work with it. We learned about a bunch of what are called code smells that indicate that a piece of code might have some opportunity for refactoring and improvement. And again, there are dozens of refactorings that have been defined out there that leverage inherent features of the language and concepts from object-oriented programming to make sure that your code is better organized and is more readable. Here are some of the resources that I use to put together these slides. I highly recommend that you check them out and add them to your repertoire in your library of references regarding software development. And that's it. Thank you for going on this rather lengthy tour of code refactoring. As I hope you saw, there are a lot of options for improving code to make it easier to work with. And having clear, reusable, and easy to understand code that can grow to meet the needs of its users is an important component of contemporary software development here at Portland State University.